Oh, okay. I am sharing. All right. I guess we're good to go. So this is the last of those kind of questions. Well, actually, forgot. It's a little bit different stuff. This, a lot of people have trouble with of scientific notation, units conversion. And then we'll do decibels, but you really don't have to really remember the formula. All scientific notation is a shorthand way of representing very large or very small numbers. So you don't have to write, 15, 20 zeros on either side of the decimal point. So they go up in powers of 10. So we represent things as 10 to a something times 10 to a power. 10 to the 0 power is going to be equal to 1. 10 to the first power, or the power of 1, is going to be equal to 10. 10 to the second power, you've probably seen it as 10 squared, is equal to 100. 10 to the third power would be equal to 1,000. So it's basically 10 multiplied by itself 3 times. If we have a negative exponent, like 10 to the minus 1, it's going to be equal to essentially the reciprocal. So it would be 0.1. 10 to the minus 2 is going to be 0.01, or 1, the reciprocal of 100. 10 to the minus 3, 0.001, or 1,000. So, I mean, that's all it is just a shorthand. And we do powers of 10. When we talk about computers and binary stuff, we'll do powers of 2, just to confuse you more. Math for electronics and conversion of electrical units. We have prefixes. We use milli, small m, to represent 1,000th of a quantity. So we can have a milliampere. Instead of 1 ampere, we have a milliampere, so it's 0.001 amperes, or amps, however you want to say it. Represented as 1 times 10 to the minus 3 in scientific notation. Or write it out as 1 little m a. That's how you normally see it written, as a milliamp, or some number of milliamps. We have a micro, which is a millionth of a quantity instead of 1,000. So we can have a microvolt, which is 0.000001 volts, or 10 to the minus 6 volts, or 1 mu volt. We use the mu symbol since most keyboards don't have it. You use a small in it. But it's actually a Greek symbol mu. We have a nano, which is a billionth of a quantity. See, we're getting smaller and smaller. So we went up another 1,000. So it's 10 to the minus 9, or a whole bunch of zeros, 1, or 1 nanovolt when you use a small n. Next comes a pico. We go down another 1,000. So it's a trillionth of a quantity. And we call these picoamperes, and we can represent it as 10 to the minus 12th, or 1 little p ampere. You probably see this more often on capacitors, where you'll have values of picofarads.
capacities, they skipped right over that N, didn't they?
They used to, but it's more common now,
Yeah.
which is weird. When I grew up, there was no nanofarad.
I've never seen one, all the time I've been working. Picofarads and microfarads.
Right. Okay,
You said you worked in AC, right? So he's seen capacitors.
microfarad, yeah. Probably hadn't seen a farad.
Pardon me?
You probably hadn't seen a farad capacitor. They're pretty big.
Well, I've seen all kinds of capacitors. I know one thing, you damn sure don't want to touch one.
All right, so we start going the other way. And we have a kilo. This one's kind of odd because we use small k. I don't know why. But it represents 1,000 of quantity, or 10 to the third. And we represent, like, we have a kilovolt, so it would be one small k V. It's important that you remember it's a small k, because all the rest of these large numbers are going to be a capital, like a mega. And we have megahertz. So it's 1 million hertz. And we represent that as a capital M Z. Next, we have a giga. And normally we talk in cycles, so we have gigahertz. Your cell phones operate at 2.4 gigahertz or 5 gigahertz. And we use a capital G there also to represent gigahertz. Now, this is just chart kind of showing all of them together.
Are we gonna have to know all of this on the test?
You'll have to do some conversions.
Okay.
So some of this, yeah. So we'll do some examples. If I wanted to convert amperes to milliamperes, okay, I know that there's 1,000 milliamperes in an ampere. So if I have 2 amps, I would multiply it by 1,000 to get 2,000 milliamperes. Does that make sense?
Okay.
If I want to go the other way, and I have something in milliamperes, and I want to know how many amperes it is. Okay, I still have 1,000 milliamperes per amp. Okay, but in this case, I'm going to divide. So I have 100 milliamperes. I want to know how many amperes it is. So it's 100 divided by 1,000, or 0.1 ampere. Now, a lot of people try to remember which way you shift the decimal point when you're going back and forth. To me, that's more confusing. Just remembering what the conversion rate is easier for me. But, whatever helps. If I wanted to go, say, hertz to kilohertz, okay, I know that there's 1,000 hertz per hertz, per kilohertz, excuse me. So I'm going to divide hertz by 1,000 to get how many kilohertz it is, right? So if 700 hertz is going to be 0.7 kilohertz. You got a question?
No, well, not really. I mean, I see what they're doing here. It's remembering.
Well, just try to remember what the conversion is, of how many whatevers per whatever. So if we had kilohertz to hertz, okay, in this case, I want to multiply. So I got 2 kilohertz. I want to know how many hertz it is. That there's 1,000 hertz in a kilohertz, so 2 of those is going to be 2,000 hertz, right? Okay, so if we're doing microvolts and I want to go to volts, I know that there's 1,000,000 microvolts in a volt. That's the definition of a microvolt, a millionth of a volt. So if I had 70 microvolts and I wanted to know how many volts that was,
You have to divide it by 1,000.
divide by 1,000,000,
Yeah.
right? Whatever the conversion is. If I had volts and I want to find microvolts, then I'm going to multiply, right? So if I'm going milliwatts to watts, so I'm going from a small to a larger one, I'm going to divide it by the conversion, which is 1,000 milliwatts per watt. If I want to go the other way and I have watts and I want to go milliwatts, since I'm going from a large value to a smaller unit, it's going to be more smaller units, right? To be equal. So I multiply it. And a few more, megahertz to kilohertz. These are more of the kind of questions you'll see, where you want to go from megahertz to kilohertz or kilohertz to megahertz. Again, it's either multiplying or dividing, depending on which way you're going. Same is true for ohms. Keep in mind that you always use a small k, kilo, as opposed to a large one, which is odd because all the rest of the large numbers are capitals. So, real question, how many milliamps is 1.5 amperes? So you want to go from amperes to milliamperes.
Be deep. Be 15.
What's the convert milliamps to, or you got amps, you want to know milliamps. So how many milliamps in an amp?
This is where I get confused.
It's just milliamps, 1,000th of an amp. So there's 1,000 of them in an amp, right?
Yeah.
Okay, so if I've got 1.5 amps and there's 1,000 per amp,
So we're talking 15,000. So it'd be C. 15.
there, very good.
I ain't never gonna remember all this. I got some studying to do, don't I?
You can miss 9.
It'd probably be on these that I miss. I don't know. I got time to study it.
Which is equal to 15, or excuse me, 1,500,000 hertz. You don't normally see it written out that way. For obvious reasons.
Yeah. I don't remember, let's see, so
Now,
we'd be
now
talking
here,
E,
now, see, they're
150.
trying to confuse you because you're given one answer is in kilohertz, one's in megahertz, and one's in gigahertz.
Right.
So you gotta pick the right one. So you probably have to work them all. So if I wanted to convert hertz into kilohertz, okay, I'm gonna divide it by 1,000, right?
Mhm.
So if I divided 1.5 million hertz by 1,000, I'm gonna get 1,500 kilohertz. Turns out that's probably the right answer, right? If I was to say how many megahertz that is, then I'm going from hertz to megahertz. There's 1,000,000. So I'd be dividing 1,500, 1.5 million by a million and get what, 1.5 megahertz? If I wanted to try it in gigahertz, I'd be dividing it by 1 trillion. So that's not gonna give me the same answer. And we already did kilohertz, so we know it's not 150. So we know it's not B, C, or D, right? We just divide it by 1,000 hertz per kilohertz. Which is equal to 1 kilovolt. No math on this one.
It'd be one thousandth of a vote, wouldn't it? Let's see.
1 kilovolt. Remember, that's the odd one
Kilovolt.
because it's larger. And a kilovolt is how many volts?
It's gonna be 1,000 votes, wouldn't it?
There you go.
You know, like kilometers, like 1,000 meters,
Yeah.
so like kilos.
See, that's why I get, I don't use meters.
There's the mirror.
Yeah, they confused a lot of things with that metric stuff. Which is equal to 1 microvolt.
Be 1,000th of a vote.
No, microvolt,
Oh.
micro.
We just went over that, so I can't even remember.
Micro sounds like a mill. Yep.
Okay, so we're talking 1 million votes on that? B,
No,
microvote is 1 millionth of a vote,
right, that's the answer.
Okay.
1 millionth.
a million.
Which is equal to 500 milliwatts.
B, be 0.5.
All right, very good. Which is equal to 3,000 milliamperes. So you only have to convert to amperes or all the same, so.
3 amps, ampers, 3 amps.
You're catching on.
Yeah, let's see if we can retain.
What is the abbreviation for kilohertz?
Well, you got to have.
I talked about this one specifically.
Yeah, you have to have the smaller, not the capital, the small letter
Right, and the capital H.
and a capital H, so we're looking at D.
All right. What is the abbreviation for megahertz?
Be capital MHD.
Sounds good to me. Which is equal to 3.525 megahertz. Now, fortunately, they're all in kilohertz, so it's just a simple. So I want to go megahertz to kilohertz.
So we go with D.
So there's
3.5. All right. So
remember,
we got to go with
there's
our
1,000
decimal.
kilohertz
So
in a
we're looking at
megahertz,
A,
huh?
A, would be,
You know, remember, there's 1,000 kilohertz and a megahertz, right? So we're going from megahertz to kilohertz. And there's 1,000 per, so it's got to be a larger number, right?
we're looking at, I'd be looking at C then, 3525.
All right. Which is equal to 28,400 kilohertz. And we want to go to megahertz. Well, there's also a kilohertz on. Which obviously A can't be right because
Well, B's not gonna be right either, it's not gonna be 2.8. So we're looking at 284 to C.
well,
It'll be either C or D. Let's see.
so we're going kilohertz to megahertz. Okay, so 1,000 kilohertz and a megahertz. We're gonna divide, right? By 1,000.
So.
A lot of people have trouble with these. Don't feel bad.
Well, I wasn't very good in math, I can tell you that. It's been a long time since I had math class. So we're dividing this and not
Right.
multiplying, right?
Right. And
Right.
divided
This
by
is
what?
a
1,000, right?
1,000.
Okay.
I'd have to write that down.
Well, or you can move the decimal point 3 places.
So we're looking at D, 28.4.
All right.
Which is a valid technician frequency.
Why they picked it. Which is equal to 2,425 megahertz. This is a standard frequency too. Just to give you a clue, I talked about cell phones.
The gigahertz is gonna be a lot smaller than megahertz, right?
Yep.
So
So we're gonna divide, right?
if I divide that by 1,000,
Mm-hmm. You're on the right track.
trying to divide my head, I need my calculator now. Let's see,
Move the decimal point 3 places to the
3
left.
places. All right. So we're looking at E, I mean A.
No, other way.
Oh, I said left, excuse me. No, it is left. The decimal point's here. We move it here. Same as dividing by 1,000.
Well, that's gonna give you, I divided 2,000 by 1,000, I got 1,000, so. 2.425 gigahertz.
There you go.
There it is.
Cell phone frequency. Which is equal to 1 million picofarads. Now, remember, a picofarad is
It's after.
10 to the minus 12. Okay, and they're giving you all answers in microfarads, which is 10 to the minus 6. So the difference is a million. Okay. So there's a million picofarads in a microfarad.
Million picofarads.
So if we want microfarads, we're gonna have a smaller number, so we're gonna divide, right?
So we're looking at C, be 1,000 microfarads. Wait,
We divide by a million in this
Because-
case.
it's smaller than microfarads, so we gotta go low.
You just divide by a million, not 1,000. Because the difference is a million per,
All right, so we're looking at this D then, maybe that'd be million microfarads.
but you're gonna divide a million by a million.
It'd be one.
How about that?
That's where I get confused. Yeah, we got some studying to do on this.
Okay, now I'm really gonna confuse you. I'll talk about decibels, which is how we measure ratios of things like gain for antennas and amplifiers and things like that. And it was developed by the long distance transmission people at AT&T Bell Labs back long time ago. They started off honoring Alexander Graham Bell with, and they called the unit bells, but it was too big. So it got redefined as a decibel or a tenth of a bell. And that's what we use. The formula is, if we're talking power ratios, it's 10 times the log base 10 of the ratio of the two values. Now, for anything except for simple ratios, you will need a calculator. Fortunately, all the questions are simple ratios, and you won't need a calculator. You just have to remember a few numbers. You'll see them represented as, sometimes it'll just be dB, it'll usually be relative to something. So when we talk about antennas, you'll see it as a dBi or a dBd, which means it's decibels relative to an isotropic radiator or decibels relative to a dipole. If you see it in a voltage situation or power, well, only power, it would be decibel relative to a milliwatt. That's the M. You may see a decibel relative to a volt. Now, you don't need to worry about it, but when we do things like volts, it's 20 times the log. It's twice as big. Because if you remember in the power formulas where we did current and voltage, there were squares. That's why the difference is 10 versus 20, because of the square factor. So if the ratio between the two numbers that you're comparing is greater than 1, the result is going to be a positive number. If it's less than 1, it's going to be a negative number. So basically, you're either have a positive exponent or a negative exponent when you do these. Again, there's the formula. At some point, you'll need to know the formula. You won't for the technician test. You just need to remember these basic things, that a ratio of 2 to 1 is 3 dB. Actually, not exactly, it's like 3.01, but close enough. A ratio of 4 is 6 dB. A ratio of 10 is going to be 10 dB. When we go the opposite direction, a ratio of 1 to 2 or 1/2 is going to be a minus 3 dB. And a ratio of a quarter is going to be minus 6. And a ratio of a tenth is going to be a minus 10. So it's the same ratios, just reciprocal, and you put a minus sign in when it's less than 1. So 3, 6, and 10 are really the ones to remember. Well, and the minuses. So let's see what the question is. Which decibel value most closely represents a power increase from 5 watts to 10 watts? So our ratio was 2, right? So if the ratio is 2, the decibels are 3.
Okay, yeah. I guess.
And if you want to work it out on your calculator, you can come up with 3.01. Which decibel value most closely represents the power decrease? So we're going to get a negative number from 12 watts to 3 watts. So it's the ratio of what? 1/4?
6, so -6.
-6.
You paid attention in math class, didn't you?
Which decibel value most closely represents the power increase from 20 watts to 200 watts? So now we got a ratio of what, 10? 200 to 20. Yeah, you just have to remember those numbers. Ratio of 10 is 10 dB. If it was a ratio of 100, what do you think it would be?
So 20 watts to 100 watts.
No, let's say it was 20 watts to 2,000 watts. What do you think it would be? Would be 10 to the 2, or as the log, so it would be 20 dB. So then when you start doing ratios of 10, okay, 10 is 10 dB. 100 is 20 dB. 1,000 is 30 dB. 10,000 is 40 dB. 1,000,000 is 60 dB. It's kind of a shorthand way to represent those ratios, because you can see, you know, you can get, and that's why you'll see on a lot of plots, the scales will be in decibels, be logarithmic. Okay, so that you can go from 0 to gigahertz in a short span, because it exponentially increases. That's what decibels do. And you can add and subtract them, which is equivalent to multiplying and dividing. Okay, so we learned all these prefixes. and what they equated to. And the formula for decibels. We need to remember the basic. 3 dB is a ratio of 2, 6 dB is a ratio of 4, 10 dB is a ratio of 10. And the negative versions of it. So there are only what, 4 questions, so you may not get a decibel question.